When I was making this video, I was seeing that a lot of people were confused with whole numbers. So whole number addition and subtraction relating to sig fig rules. So we're going to do the next few examples relating to whole numbers. So we are going to start by doing the math, and then I will explain the rules. So 104 plus 50 would be 154. Okay, so with whole numbers, you basically have to see if any of them have trailing zeros, okay? Like the 50 here. So what makes this important is we don't know if the 50 was rounded from 45 or 54, okay? You'll notice that if the number was even as low as 45, 45 rounds to 50, and as high as 54, 54 rounds down to 50. So this 50, because that zero is uncertain, this 50 could have been anywhere from 45 to 54. So that makes that number in the ones place uncertain, okay? So the only number that we're certain of in the 50 is the tens place. And because of that, our answer will be uncertain in the ones place because 50, when there's that zero there, that makes it uncertain. So what we do is basically the same thing we did with the first examples, is we're saying that that ones place is uncertain. So we're seeing if that can round to anything, and it does not. So here our answer is 150 because the ones place is uncertain. Okay, let's do another example. So now you'll see that both the 100 and the 50 both have zeros. So first we're gonna do the math, and then we're gonna start highlighting things. So again, we're just gonna drop down anywhere where there's a zero with that highlight, okay? And we're dropping down until there's no more zeros on either of the numbers. So in this case, you'll notice that both of them have zeros. Don't let that trip you up. So if it was an example just with the 100 and like 55, it still would be both of these. Or if it was like the 50, like this example here, it would just be that ones place. Okay. So both of these are uncertain because those zeros aren't significant. So we're not sure what those numbers actually should be. They might have been rounded. We don't know. So we'll do the same thing we did before, is we'll take the number closest to what we're going to keep and we'll see if we can round. And here we can, and your answer will be 200 then for this problem because of the uncertainty in those zeros and the precision. So let's do another example, 250 minus 5. Again, let's do the math first. 250 minus 5 would be 245. And again, we just take our highlighter and drop it down until you hit the first non-zero number. And in this case, it comes immediately after that first one. And we're going to see if the 5 can round to anything, and it can. So here our answer is 250. For this example. Okay, let's do the next one. So we'll take 12,000 plus 5,300. And again, we're just going to do the math before we talk about any of the precision. And that would be 17,300. Okay, so again, we're just going to drop down when there's zeros there. Okay, and now there's no more zeros left. So we are going to take this and round, and that does not round. So our answer is this. Okay, last example with the whole numbers. So again, we're just going to do the math pretty quickly. 670. And you are going to take your highlighter. You're going to take the highlighter and go down until you get all of the zeros taken away, which is right there. And then you will see if you can round, and you can, and your answer is 700. Really quickly, I want to go back to this specific example and say that this example, this number could be anything from 150 to 249, okay? It's not really 200. You're not really saying that the number is 200. This number is really encompassing, saying it really could be anything from 150 to 249 because of rounding, right? In any of that range, the numbers would round down to 200. So that's why if you're confused, if you're like, but 100 plus 50 is not 200, these are the sig fig rules. And it's essentially saying that we're saying it's 200 because of the precision, but technically, if you think about the logic behind it, the rounding saying it's anything between 150 and 249. And these examples are really indicative of why scientists measure to multiple decimal places, because you really don't want this degree of variability, right? This is almost 100 numbers. You really don't want that. So that's why you want to add more significant figures and more decimal places to make your number more precise and a smaller margin of error in your measurement, which is what we talked about originally with precision. Thank you so much for watching. Please comment below any questions you have and let me know what topics you would like covered next.